Okay, lesson 5, or notes 5, graphing linear relationships. Okay, let's take a look. You need a ruler. Have a ruler of some sort, straight edge, whatever. Okay, for homework, Sarah must graph a line passing through the points -3, and 3, 3. Graph Sarah's line on the grid below. Okay, -3, -3. Excuse me. That's the first one, and the second one is +3, 3. 3, 3. That's my ruler. And when you graph a line, you want to go the full graph, nice and across. Put a little arrow on the end, Beautiful, nice and straight and crisp and perfect and neat, right? It's easy enough, okay? Next one. Graph a line that goes through these following 2 points. -4, 3, and 2, -1. Okay. -4, 3. Oh, this line did not come out for some reason. Okay. -4, 1, 2, 3. And 2, -1. Over 2, down 1. There you go. Notice my line all the way across the graph, all the way. Not just between the dots, all the way with arrows on the end. Very important, okay? And you should use a ruler. All right? That's all they asked you to do, okay? Now, what kind of slope is the top one? Is it positive or negative? My brain sees it from the left side over, so it is going uphill. It is going to be a positive slope. Okay? Can we take the 2 points that were given to us, and from those 2 points, we can almost actually see it is a perfectly crisp in every single corner. Am I right? Corner to corner to corner to corner to corner to corner. Right? So my 2 points, again, were -3, -3, and 3, 3. If I use my slope formula, m equals y2 minus y1, 3 minus, 3 minus -3, all over x2 minus x1, 3 minus -3. What do we get? 3 plus 3 makes 6 over 3 plus 3 makes 6. 6 over 6. This is my rise. This is my run. And 6 over 6 makes 1. Right? 6 over 6 is 1. Let's do this here. If I want to make a perfect triangle, or right triangle, or the step, my run and my rise, could I run all the way across here? I could do this in red so you can see it a little better. I think I can do it in red. If I go all the way across here and get to the other dot, how many units did I run? 1, 2, 3, 4, 5, 6. I ran 6 and I rose 1, 2, 3, 4, 5, 6. Rise over run, 6 over 6, it's 1. If I did it by little boxes between the 2 perfect points, what do you get? Perfect little 1 over 1, over 1, up 1, over 1, up 1, over 1, up 1. Same thing. So whether I did it for the full extent and up, you will get the same value once you simplify or reduce. Okay? Let's try it down here. Downhill line, downhill. So definitely going to be a negative slope. A definite negative slope. Okay, so what do we got? We have 2 points. -4, 3. And the other point was 2, -1. So again, y2 minus y1. So m is -1 minus 3 over 2 minus -4. So on top I get -4. On the bottom, what happens here? That makes plus, makes 6. So technically, okay, if I remember change in y over the change in x, this is my rise, and this is my run. So I'm going to run sideways 6 boxes, but I'm going to go down 4. So between the 2 dots, let's just take a look at that. Between the 2 dots, is that what I'm doing? And to make that triangle, okay? If I go down 4 from this dot, 1, 2, 3, 4, looky, looky, and run all the way across. How many boxes did I run? 1, 2, 3, 4, 5, 6. There's my 6. And what's my rise? 1, 2, 3, 4, 4. Rise over run. This is a downhill line, hence -4 over 6. Okay? Just kind of a little tidbit of info here. This is all going to start coming together nicely. That was just kind of a warm-up of our lesson. All right, next page. Oops, that one's already done. Let's look up here. Okay, for starters. Okay. Graph a linear relationship based on the information provided. Oh, so we have given the slope, 2 over 3. That's my rise, that's my run, and my y-intercept is 3. Oh, this is interesting. So my m is 2 over 3, and my b, my y-intercept, is 3. So y equals mx plus b. Y equals mx plus b. That's the form of the equation. I'm going to write out 2/3 x and a positive 3. That's my equation. Okay. So the line has to go through positive 3 on the y-axis. That's what the y-intercept is, positive 3. So I have to go over to positive 3 and say, yep, the line's right going through there somehow. It is going through positive 3. This is telling me its direction. It's telling me if it's positive or negative. And it's positive because 2/3 is positive. So that means my line is going uphill. So that means it's going this way somehow. How exactly is it going? Based on these boxes. Rise over run. Okay? So if my slope is 2 over 3, the 2 represents the rise, and the 3 represents the run. So from this circle, this dot at the y-intercept of 3, I can run 3 boxes to the right. Because I'm going to go positive, I need to go up. So I'm going to go 1, 2, 3. I'm going to lightly go over 3, and I'm going to rise 2. 1, 2. And that's where my next dot will fall. Okay? Now watch carefully how I do this next one. So now I have a visual that the line has to be doing this. So the next dot is somewhere down here. How do I know exactly where it is? I'm going to do exactly what I just did here. The rise and run, right? Run. The rise was 2, but the run was 3. So I can do, okay, what if I just kind of went down 2? I have to go backwards 1, 2, 3. There's my next perfect dot. If I follow the same pattern of rising 2, running 3. Rising 2, I go down 2, and I'm going to run 3. It would be off here. All right? Another way of looking at it, rise 2, run 3. rise 2, run 3. Either way, I'm getting to the same kind of direction. All right, take my ruler and very neatly, crisply draw. Notice, guys, I always extend it beyond the graph. Okay, let's repeat. I'll go over how I did this. Given the y-intercept was 3, I know on the y-axis I got to go to positive 3. There it is. Put a big bullet dot right there. This is the circle that the line runs through. In what direction and how many units does the line run? You use your rise and your run, your slope. Okay? Run 3, rise 2. Why am I rising? Because 2 is positive. Okay? All right, let's try this one. Okay, this next one tells me, oh, the slope is 0. The m is 0. Well, pages before, anytime we had a 0, what kind of line was it? Flat line. The y-intercept is 1. Crossing at 1, positive 1. Positive 1 right here. And I need to make a flat line. Hey, this is a no-brainer. Flat line at positive 1. Done. This equation is y equals 1. Okay? Let's look at this one. Ah, the slope, the m, oh boy, the m is negative 2. What does that mean? So if I think of the words, the m again is the rise over the run. And they're telling me it's negative 2. Okay, watch, guys. When you have a whole number as your slope and it's negative, so that means this line's going downhill. The rise is negative 2, meaning it goes down 2. Guess what the run is going to be? 1. Because you can always put a 1 under a number. It doesn't change the value. That still has the value of negative 2. The y-intercept, the b, is at positive 2. And this is on the y-axis. Okay, so go to my picture. Always start with the b. The b is positive 2. So I'm going to find positive 2 on the y-axis, right here. Put a dot. We good? Positive 2 on the y-axis. Oh my goodness. Line's going downhill because it's negative. Rise over run. I'm rising negative 2. Am I going to go up? No. We're going from this dot. We are going to count down 2 units. 1, 2. And then the run is a simple 1 over 1. Put a dot. Again, so I started at this positive 2 on the y-axis. My slope is negative 2. That means go down 2. 1, 2. I can't, if I'm not putting a dot there, because then I would have a vertical line, and that's undefined. There is no such thing. So I have to go down 2 over 1. And I'm going to keep doing that exact same pattern based on my slope. Down 2 over 1, put a dot. Down 2, over 1, put a dot. And it would continue. Now, if I want to go the other way, could I go up 2? But am I going over here? No, it's a straight line. Up 2 over 1. That's your negative move. Okay? Take your ruler and connect them. Put the arrow, put the arrow. And I could write the equation for this. Y equals the slope negative 2x. And I could put it over 1, that's okay. And where is it crossing? At positive 2. Okay. Let's try this one. All right, so my M again, notice why I'm writing this, so I'm remembering it. M equals the rise over the run, and in this case, it's -1 over 4. So negative slope tells me it's going downhill. And this is my B. My B is -1 on the y-axis. Very, very important you understand that. That's where you start. Start at the B. Oh, I start at the -1 on the B. So I go to my graph and I find where is -1 on the y-axis, right here. Boom, -1, put a dot. Next, take my slope. Rise and run. I personally like to do I could do my rise first. Is -1. -1. Negative means go down. So I go down 1, but I'm running 4. So I go, okay, run 4, 1, 2, 3, 4. Put my next dot. Okay? I could keep going, but I'm not going to fit it on this graph. Down 1 and then over 4, so it would be like way out here somewhere. But can I go this way? I know it's got to be over this way because the line is doing this direction. So if I go up 1, that happens to be positive, but I know this line is negative, so my move will be backwards 4. Same thing. Or go backwards 4 and up 1. Either way, the rise is 1. 1, 2, 3, 4. There you go. Okay? So if I had to make my set of stairs, they were kind of long stairs here, long and flat. And my line would be doing this. Okay? Notice it's 4 and 1. 1, 4, and so on. 1, and that would get to 4 out here someplace. So my equation for this one, all right, putting it all together, y equals -1/4, got to put an x in there, 1/4 x, and my b is a -1. So when I look at my picture, I started this line at -1 on the y, and my slope gives me how the line is running. It was 4 units over and 1 down. Hence the negative line. Okay? So let's kind of look at this one again, just refresh our brains. If I look at this equation, this tells me I start on the y-axis, at 2. And how did I get to the next dot? Based on the slope is downhill, because it's negative. It's down 2 and over 1. The rise and the run. Okay? Down 2 over 1. This one up here, it gave us the slope of 0. So if it's a slope of 0, I know it has to be a flat line. And it's telling me the line's crossing at the y-intercept of 1. So it's right there. Straight across at y is 1. And the top one, let's review again. The y-intercept is 3. That's your B. And so I go to the 3 on the y, right? Here's our y-axis. Go to 3. And I follow my slope of the rise is 2, and I run 3. Whichever you want to do first. Run 3, then go up 2. If I rise 2 first, then I run to the right 3. And I know it's positive. It is a positive 2/3. That's why it goes up. So having your slope as a fraction is okay, because you just use the words. The rise represents the top number. The bottom represents the run. And if you don't have a bottom number, you technically do. It's the number 1. The run will be 1. Got it? All right, I hope we can practice some on our own. All right, try these. So this one is supposed to graph here, this one graphs here, and so on. I will help starting identifying the m and the b's, and then you're on your own. Okay? So in this case, the slope, is 1/3, and it's positive. The b is -2. This is where you start on the y-axis. Okay? Let's read this one. Your m here in front of the x, believe it or not, is a -1. That's your slope. And your b is +5. That's your b. b equals +5, and that's on the y-axis. Notice I'm accentuating that. You got to remember, that's where you start. Start with the b. Start here. Okay? So you're going to put them down here, and you're going to run negative down 1 over 1, down 1 over 1 over 1. Okay? I'm going to set you up for this one. So the m here, the m in this one is a -3 over 2. Again, remember, rise is your top number, run is the bottom. Negative slope, going downhill. The b is a +3 on your y-axis. This is where you start. And this one, the m is 3, so 3 by itself is simply 3 over 1. Your b here is -1. Again, this is on the y-axis. Okay? This is where you start. This is on the y-axis. Find +3. Okay? The rise and run, sorry, back up here, was just put it over 1. Remember, when you don't have a denominator for the run, it is always 1. Okay, that should be enough for you to practice right now, or homework. Okay, I hope you did this on your own, but I will do them now just in case, and it's a good way of checking it. Since I already identified all these, I may move a little fast. The b is -2. I'm starting on the y-axis at -2. Put a dot. This is my steps. Okay? Rise over run. Rise 1, run 3. Rise 1, run 3. 1, 2, 3. Put a dot. Rise 1, 1, 2, 3. This is actually off the chart. Okay? So I'm going to go backwards so I can fit this, but I know the line's doing this, so I'm going to go down 1, 1, 2, 3. Same thing. All right? You technically only need the 2 dots to make your line, but I always like to do a little more. Notice my line is completely through the graph with the arrows. No excuse not to do a good crisp line with a ruler. Okay? So this graph is this. This is y equals 1/3 x minus 2. All right? Now I'm going to do this one here. Where do I start? At the b, a +5. I'm way on the top. But my slope is negative. And it's a -1, -1, 1. So I know the line's got to go in this direction. Somehow running downhill. So I go rise over run. My rise is technically a -1, so I'm going to go down 1, but then over 1. There it is. Down 1, over 1. Down 1, over 1. Down 1, over 1. You get the point? Whenever your slope is that 1, it's real easy. It's just going by one little boxes. And I connect my dots. Draw my crisp line, put my arrows on the end, and write the equation next to it. Y equals -x plus 5. Started at 5 and did a slope of negative. Got it? Let's go to this one. Okay? All right, I start at, the b is +3. On my y, I go to 3. Got it? My slope, rise and run. The rise is a -3. means it's going down. This is a negative line going downhill. So down 3 over 2. 1, 2, 3 over 2. 1, 2. There's my next dot. Down 3 over 2. 1, 2, 3 over 2. Got it? Put down my ruler. Please respect the rulers if you're using the rulers from the classroom. There you go. Started at positive 3. It had a negative slope going downhill. How did it exactly go? Down 3 over 2. Down 3 over 2. And the pattern would continue. This one starts at the y-axis is at negative 1. So I find negative 1 on the y, put a dot. I look at my slope is positive. So this line means it's going up. From left to right goes up. How is it going up? 3. 3 over 1. So technically I'm going to rise 1, 2, 3 and go over 1. 1, 2, 3 over 1. Okay? Take my ruler, and I could do the next one here. I go 1, 2, 3 over 1. It gets the same pattern. You can see where it continues. Perfect. Ta-da, ta-da. This equation is y equals 3x minus 1. I should have wrote the equation over here. And this was y equals negative 3 over 2x plus 3. Got it? I hope. If you didn't, figure it out. Replay this. Okay, let's go to the next page. Okay, this is a question from a state test. Eric is assigned to graph the line of this equation, y equals 2x minus 3. Use Erica's equation to complete the table below for the given values of x. Oh, so they're telling me when x is negative 1, when x is positive 1, when x is 3, what will my y equal? So basically you have to plug those values of x into the equation and work it out. So I'll do it on the side here. So if the first one says, if x is negative 1, y equals 2 times negative 1 minus 3. That makes negative 2, negative 3, makes negative 5. So y has to be negative 5. The next one says if x is positive 1, y equals 2 times 1 minus 3. That makes 2 minus 3, so that makes negative 1. So the next one, y has to be negative 1. And the last one, okay, if x is 3, y equals 2 times 3 minus 3. 2 times 3 is 6, minus 3 makes 3. So I go 3. Using the information from the table, graph the line, the same line, y equals 2x minus 3 on the graph below. Well, guess what, guys? I could do it two ways. I could take these points and graph it, or I can figure out the m. The m is 2 over 1, the rise and the run. So this is the rise, and this is the run. And the b is a negative 3. But we're going to do it the old-fashioned way. We're going to take the coordinates first. Negative 1, negative 5. Negative 1, negative 5. 1, 2, 3, 4, 5. So one dot on the line is there. You with me? 1, negative 1 over 1, down 1. Second dot is there. And the third dot is 3, 3. 1, 2, 3, 1, 2, 3. And if I draw my dots, my line, guess what? Where is it crossing the y-intercept? Oh, right there. negative 3. That's one of the dots. What is the slope? Rise, run. From here, I rise 2, run 1. Rise 2, run 1. Rise 2, run 1. There we go. It's there. 2 ways of graphing. Table of values that belong to the equation, that work in the equation. Okay? Or taking your slope and your y-intercept and graphing. Either way is acceptable. In algebra, you'll be doing the slope and the y-intercept. Okay? Let's try this one. Can use the function rule below to create a number pattern. Well, guess what? This is a linear equation. It's not quadratic. There's no square in it. It's not absolute value. This will graph as a line. Okay? Let's fill in the table of values that belong there. So, if x is negative 4, now you definitely need some scrap paper doing this. Don't try doing this in your head. Y equals 2 times negative 4 plus 2. That makes negative 8 plus 2 makes negative 6. Negative 6 goes here. Let's do the next one. Put a negative 2 in there. Y equals 2 times negative 2, okay, plus 2. That makes negative 4 plus 2. That makes negative 2. So next is negative 2. Got it? Love the 0. You'll see why. Y equals 2 times 0 plus 2. That's always 0 plus 2, so I get 2. So it's 2. Do you see a pattern? What do you think this one's going to be? It says going by what? By 4. So let's see. 4 more there would make this be 6. Let's see if that works. Y equals, put a 1. 2 times 1, it's going to be a 4. 2 times 1 is 2, plus 2 makes 4. Oh, the reason is because we're jumping a little bit. We don't have a consistent pattern. They just some random numbers in somewhat of a sequential order, but it's not a consistent. Okay? Let's put 3 in there. The last one is y equals 2 times 3 plus 2. That makes 6 plus 2 makes 8. Okay, so now let's do the m and the b. Y equals 2x plus 2. What's my m? My m here, my slope is 2 over 1. This is the rise over the run. And what's my b? My b is positive 2. That's where I'm going to start, or should start. All right? Now we're going to graph this down here. I could do it by the points, or I could do it the shortcut. This is the shortcut method. Either way, we're going to get the same line. We better. So, negative 4, negative 6. Negative 4, negative 6 would be this dot right here. Negative 2, negative 2, negative 2. Be that dot. 0, 0, 2. This way. 0, 2 is there. 1, 4 over 1 up 4 is here. Over 3 and up to 8. 6, 7, 8. Because we jumped. They skipped number 2. But you could figure it out if you had to. Are the dots in a line? Yes, they are. They have to be. If I did my math right over here, definitely forms a line. Okay? Let's look and see if I could have got it this way. Crossing the y-axis at 2. Crossing the y-axis at 2. What's my slope? Rise 2, 1, 2, run 1. Rise 2, 1, 2, run 1. There's another perfect dot. So if x was 2, it would be 6. Okay? Same with over here. We can get the next perfect dot here, and so on and so on. Same thing. Doing this requires your algebra to be good, your positive and negatives, and working it through an equation, working it through the function machine. We fed the machine the input values here, the input values of x, which is the domain, to create the range, and the y, which is the y values. It's specific to this function machine. A shortcut way of looking at this based on a graph is to take the m and the b out. The m is your slope, and your b happens to also be 2 crossing the y-axis. Got it? We having fun? Did I hear a yes? This is all homework, okay? Homework or practice work. So I would suggest you try it. You're graphing the points, connecting the dots, you make a line. Graphing the 2 points, connect the dots, make the line. No brainer. What I'd like you to try to do is write the equation. It might not go through the perfect y, we'll see. Okay? Try it. I'm going to turn it off.